Okay, surface area. That's what we were talking about. Let's say that this is like 6, 5, 12. Okay, so if I wanted to find the base area for this rectangular prism, what would I do? How would I find the base here? 6 times 5, because it's just a rectangle, right? So it depends on what the base is, what formula you use. If it's a triangle, you do base times height divided by 2. If it's a rectangle, just 6 times 5. Okay, so that would be the base area. What if I wanted to find the lateral surface area? The middle part. Okay, I could do like 5 times 12, that would be all this. 6 times 12, that would be all this. And just go all 4 sides around and add them together. But what trick did we use yesterday instead of doing that? Or what trick did I use anyway? I did the perimeter of the base. So you guys know the difference between perimeter and area?
Yeah.
Perimeter is how many around it is. So it's like 6 plus 6. You guys ever watched a war movie and they say like scout the perimeter? It means just walk around the perimeter and see if anything's going on. So just walk around the edge is what it means. So perimeter is just adding the edges. Area is we do by multiplying because it's how many squares fit inside. Anyways, if you do the perimeter times the height, that gives you the lateral surface area. Because remember me talking about like if you use scissors and cut it, it just makes like one big rectangle. And the perimeter is like the bottom and the height is like the height of the rectangle. Anyways, lateral area. I know people have a hard time comprehending this. Remember I did say though that I'm not going to make you memorize these formulas. You'll just have to be able to plug stuff in basically. So lateral area would be 6 plus 6 plus 5 plus 5. That would be the perimeter. Times 12. Perimeter times height. I don't know what that is. Whatever. Actually, I'll figure it out. It's 22 times 12. 220 plus 44, 264. Okay, what if I wanted the total area though? This is what we were doing on the last section. Right. So if you think about it, we're splitting it up into 2 parts. There's a base on top, a base on bottom, so 2 of these. And then there's the middle part, which they call the lateral area. And that's this part. So 2 of these plus this would give you the total. So 2 times 30 plus 264. Alright. That's the idea. Is this kind of making sense to you guys? I don't know. Where are you at? Better than yesterday? That's good. I'll take
Yeah,
that.
I think it makes sense.
Okay, thank you, Caden.
It makes sense.
Alright. I know, I understand a lot of people don't get it very well, but. And plus, we talked about like 50 formulas yesterday. A lot of them were from chapter 7, but still, I know there's a lot of stuff we're throwing around. Anyways. And then on cylinders, it's actually the same idea, but it's just that the formula for cylinders is circle formulas. So the base, well, how do we find the base area of a cylinder? Guys, you need to stop working on it and pay attention. How do we find the base area of a cylinder?
It's like pi
Pi r squared. Because it's a circle. And then, well, this is the harder question. I wrote this down yesterday, but how did we find the lateral area of the cylinder? Yeah, I'm guessing you guys did that from your notes. Yeah, it's instead of perimeter times height, it's circumference times height. So it's the same idea. And then the total area, it's the same thing. Its total area is two bases, two of these, plus this, whatever that is. So I guess you could write it out. 2 pi r squared plus 2 pi r h. Alright. Shoo. Number 10. Anybody think they figured out 10 already? I'm not doing it, but I'm going to help you.
I think I got it, I'm not sure.
Well, what's hard about, what's the trick with number 10? Why is there a problem? Oops, that was a mistake.
We don't know, like, anything.
What'd you say, Issa? Well, yeah, you have to do base times height divided by 2, but what's the base and the height? That's the problem.
Yeah.
Well, okay, on the bottom of the cylinder or prism it says 8, and since the bases have to be identical, this has to be an 8 also. There's something special about 6, 8, and 10. 6 squared plus 8 squared, guess what? Equals 10 squared. So what does that tell us?
Right.
It's a right triangle. So how would I find the area of this base? Or capital B base. 6 times 8 divided by 2.
Yeah.
And then you have to multiply by 2 because there's 2 of them. But remember we were doing the lateral area first, and then we did the total surface area second. So for the lateral area, you have to do the perimeter of the base times the height of the prism. So that plus that plus that, whatever that is, times 12. That's lateral. Okay. It's floating away. Number 11. Now, on to the odds. What shape does number, I'm not sure I can draw that perfectly. What shape does number 11 look like though?
Something really.
Looks like a trapezoid. That pretty much has to be what they were going for. Yeah, that's pretty good. Whoops. There we go. 38, 21. So you need the trapezoid formula. 18, 29, I think I got them all. Inches. But actually, we're going to start with the lateral area. So we don't need the trapezoid yet. Okay, what was the lateral area formula? Those really short formula? Perimeter times height, pH. So, perimeter, if this is an 18, this is an 18. If this is a 29, this is a 29. So the perimeter would be 29 plus 21, 50, plus 18 plus 38, 56. So that'd be 106 inches. And then you do that times the h, the height of the prism is 34. So it's 106 times 34. Oh, said 3604. Let's see if she's right. Yes, she is. Okay, now to find the total area, what else do I need besides the lateral area, which I just did? The two base areas. And the two bases are trapezoid. So I'm going to do a trapezoid area times 2. Let me draw a miniature version of the trapezoid here. So we got 29, 38, 21, 18. You guys remember the trapezoid formula?
Base 1 plus base 2 divided by 2 over half or times
Okay. What are the bases?
18.
18 and 38. What's the height of the trapezoid? 21. Yeah, that might be. Okay. After I do this gives me a trapezoid. What do I do after I get the trapezoid? Times 2. Actually, you can kind of cheat here and do this. But, or you can just plug it all in, it doesn't matter. $56 times 21. I don't know if I can do it. 1,120 plus 56. Is that all right?
Yep.
Okay, that's the two base areas because we did it times 2. So we just add the two base areas to the lateral area, and that's the total area. 3604 plus 1176. 3780. Whoops, 4780. No. Okay. I give up. Whatever. All right. Okay, number 13. This figure represents a square mine shaft from which rocks have been falling. How much sheet metal is needed to cover the sides of the shaft as a safety measure? So how many square feet of sheet metal do we need? Okay, what sides would we have to find the area of if we're trying to, for the sheet metal? Do we need the top?
No.
Do we need the bottom?
No.
No. Do we need the lateral?
Yeah.
Yes, so basically, yeah, the top of the shaft would be like, opening into the, it would be like the top of the elevator. The bottom would be the ground. You don't need to cover the ground with sheet metal. It's just to keep the walls from caving in. So the sheet metal will go on the lateral surfaces. How did we find lateral surface area? Perimeter times height. So what is the perimeter of the, it said a square shaft, so what will the perimeter of the square be? 7 times 4, yes. 7, 7, 7, 7. So it's 28 for the perimeter, and the height of the shaft is 31. Whoops. All right. 14 says a water tower is a right circular cylinder. What do they mean by a right circular cylinder? What they mean is it's at a right angle with the ground, so it's just going straight up, which is everything on this page is a right prism or cylinder. So it's not like leaning over like the Tower of Pisa or anything. It's just going up. So it doesn't really mean much. 21 meters high, radius of 7 meters. It's kind of like the, the water towers Bartlesville has that says hot. What does it say? Hot and cold? Hot, warm, and cold.
Isn't it like a jug or something?
Yeah.
Yeah, that's not how it works. The water is heated in your house, not anyway. Determine the area to the nearest square meter, so we're rounding to the ones place, that needs to be covered if the exterior is painted. So if we were painting this, would we need to paint the top?
Yeah.
Yeah. Would we need to paint the sides? Would we need to, oh boy, would we need to paint the bottom? I don't know how you'd paint the bottom of the water tower. That'd be hard.
What's up with the exterior?
I don't think the bottom would count. Can you explain to me how you're gonna paint the bottom?
Lift it off.
Or why you would paint the bottom?
Why would they paint it?
I'm imagining Issa like,
She can't lift something up. Girl, you
look at
can't.
those. Issa, show us your guns.
Yeah, show them your strong.
Bam!
Wow, you're so white.
Fire.
Hope just says, wow, you're so white.
You're a little vampire?
I was just saying,
Oh,
like,
no,
so
no, that's fine.
Pretty different situation.
Yeah, so you need one base and you need the lateral. Okay,
How do you
moving
have the
on.
bases again? Is it like pi r squared?
Yeah, the base is a circle, so it's pi r squared.
Oh.
Just depends on what shape you're doing.
Do we have to multiply it by 4 or is it just write it down like?
Well, the book did both. I have been not multiplying by pi, just putting it in the answer. But the book did put both answers on all these. Actually, no, I lied. On 14, it says round to the nearest square meter. So you do need to plug in the pi and like round it off.
So we only need to
Well,
find
rounding to the nearest square meter means rounding to the one place, basically. Okay, it is story time in math class.
No.
While experimenting with boiled grains in an attempt to find an easily digestive alternative to bread, John Harvey Kellogg, a medical doctor in Battle Creek, Michigan, accidentally discovered a method for turning grain into a crispy flake. A patient at his sanitarium, C.W. Post, was impressed with Kellogg's food products and developed his own cornflakes. So Kellogg's and Post, they were like knew each other. That's interesting, isn't it? Okay, Post marked the first cornflakes in 1904 under the name Elijah's Manna, very biblical, and renamed the product Post Toasties, not biblical, in 1908. What is the shape of the Post Toasties package? Rectangular prism. Now you guys know the history of cereal.
Box. Oh, it is?
Okay, just a box. Guess what you have to do on 16?
Do you think that people
Measure.
Find the surface area.
Hey, can you think people do drug deals in like cereal boxes?
Wait, what are we going to? Yes.
We're going to 18.
They just like
Oh,
pack it in
I
cereal.
thought
you said
Hey,
60.
want some
You
of
said
my
60s.
Rice
You wrapped
Krispies?
drugs in.
I lied.
We're going up every time.
Tacos?
My prerogative.
What are we going to? We're gonna be at like 40 later. 18. Jeez. I swear, Grant needs
Yeah, I could.
Grant needs to like mail it to chaos.
Okay, if the cereal were marketed in a circular cylinder,
What's the circumference?
They're also both so.
2r pi.
Yeah.
Can I give you this spoon?
Oh, you were talking to her.
Candy bar. Eat that. A little 12-year-old is playing.
Okay, let's keep our hands to ourselves.
So,
So, the radius is 2.5, and the height is 9, and what should the total surface area be? Okay, you guys remember how we did cylinders?
yes.
Let's start with way up there is the formulas. I wrote it at the beginning of class. But 2 base areas, 2 pi r squareds, plus the lateral area is circumference times height. I think I wrote the letters in a different order than I did last time, but it doesn't matter what the letters order is. Okay, so we're just going to plug these numbers in. 2.5 is the radius, 9 is the height. So 2 times 2.5 squared times pi plus 2 times 2.5 times 9 times another pi. Makes a big number. They did write the answer both ways. They put 57.5 pi square inches, which is the same thing about as 180.6 square inches.
We're not here. Oh, it's cold.
No.
I'm hearing despair.
It's like a ticking time bomb.
Hope's twin sister.
Man,
Meh.
Taking the time ball. Stop.
I didn't taking time bombs away.
Here's what I was doing.
Oh, what is it?
No, I didn't use that.
Depth is away from you.
That one has to do with this.
Depth of field, like
So like, yeah, right there.
Yeah.
So is this the
Uh,
answer? Or do I-
depth